So today we're going to be reviewing using formulas and substituting numbers into those formulas. So something you've been doing again for a really long time. This all should be review stuff. But we're going to go through some different types of formulas and make sure to cover the basics so that as we're using formulas, because we're going to use a lot of them this year, you are using them correctly. So first things first, to use a formula, you need to be given a value for all of the variables except for one, okay? You can use formulas without all of the variables, but you're not going to be able to solve anything. So in order to actually use it and come up with a solution, you need to have a number, a value for each variable except for one of them. And then the one you don't have is the one that you're looking for, right? So the steps that you go through, we can kind of call these, let me get this out of the way. We can kind of call these our steps. First thing you do is you replace each variable with its given value. So if P is 7, you replace P with 7. If W is 89, you replace W with 89. The thing that you need to be careful about is that when you replace that variable, you put the value in a parenthesis, okay? So make sure that you put the value in a parenthesis. We're going to do some examples right here in a minute. So let's go right down to our temperature formulas. So I gave you a lot of formulas on this review sheet. We're not going to use them all today. They're not ones that you have to memorize, but a lot of them we are going to use throughout the year. But they're just different formulas that represent all sorts of different things. So these formulas right here at the top for temperature show you how to do a couple of different things. The first one tells you if you know the Celsius temperature, how to convert it into Fahrenheit. The second one goes the opposite. If you know the temperature in Fahrenheit, how do you convert it to be Celsius, right? Because not everybody uses Fahrenheit, not everybody uses Celsius. It's one of those annoying units that we have to convert back and forth sometimes. So if I were told that C was equal to 5 degrees, so I know that C is 5 degrees, but I don't know what F is. It doesn't give me a value for F. Then I want to plug in that 5 where the C value is. And when I do that, step 2 says to always write this step on your paper before you plug it in the calculator. That one's a big one today because a lot of these formulas can get kind of messy and they don't always look good. So when you're typing them in the calculator, you want to make sure that what you write on the paper looks the same as what you type in the calculator. If you don't do both, you don't have those versions to compare and make sure it looks correct. So I'm going to replace the C with a 5, and I end up with F equals 9 divided by 5, parenthesis 5, plus 32. So when I replace the C, I put that number in a parenthesis. You are going to do that every time you substitute because after that, a lot of the times, all we have to do is plug in this side to the calculator. The calculator doesn't know, well, the calculator knows how to do math, but it doesn't know what you want it to do if you don't tell it. That parenthesis helps the calculator do things in the right order. And it's not always necessary. Sometimes the calculator will still do it correct without the parenthesis, but there's a lot of times that the parenthesis helps it do it in the right order, so it's a good habit to just get into. So step 3, if the variable that you don't know is alone, so that F, let's fill this, whoa, what's going on? Take it easy. If the variable that you don't know is by itself, well, we don't know F is by itself, it's alone. We plug the rest of the equation that we wrote right into the calculator. So that yellow part, I'm just going to plug right in the calculator. I'm going to make sure it matches what I wrote on my paper. The calculators that we're going to be using in class have something called Math Pretty Print. It is the greatest invention, the greatest update to calculators ever, because you can make it look on the calculator like it looks on your paper, which helps you avoid a lot of mistakes. So I plug in the 9/5 parenthesis 5 parenthesis plus 32 into my calculator. I hit enter and I end up with F is still alone on the left, but on the right, all of that mess now becomes 41. Okay? Same thing if I was using the other formula. So if it gave me, let's say it didn't give me C instead. Let's say that it gave me F. I don't know. Let's say F equals 40. I'm going to use this formula. I could use the first one. In fact, we'll do that in an example. But this time, instead of replacing the C, I'm going to replace the F. So C equals 5/9 parenthesis. Now the F is going to go in its own parenthesis. So 40 minus 32 parenthesis. That looks a little messy written down on paper. When you type it in the calculator is going to make sure that it does the math in the right order because you put that 40 in parentheses. Well, step 3 says if my variable is alone, C is alone. So I just plug the rest of it into the calculator. And so this right-hand side, I'm going to plug it in the calculator, make it look exactly the same. And I'm going to end up with C is going to equal nothing super nice. We're going to end up with 40/9, a fraction, which is okay. Numbers don't always come out nice. You are more than welcome to turn that into a decimal, mixed number, however you want. I love this answer because it's precise, it's clean, and I'm okay with that. So you don't always have to reduce in this class unless something tells you to, but you're welcome to. As long as your decimal is correct, I'm going to give you credit for it. Now, what do we do if the variable that we're looking for is not alone? So this is also step 3, but it's a different step 3 because it's what we do if the variable is not by itself. So let's say I had this same situation with the temperatures, but it did not give me the formula for Celsius. If I only had the formula for Fahrenheit and I had to find the Celsius degree given the Fahrenheit degree. Well, when I plug that in, I've got 40 over here, and then I've got 9 divided by 5, C plus 32. I don't know why I wrote 32 weird. It's like I was going to make it a fraction. So in this case, the variable I'm looking for is not by itself. You've been doing this since, I don't know, 6th grade. So from here, you know how to solve them. All you have to do is get the variable alone. So the phrase that you used a lot of the time in the younger grades, and we've kind of just ran with it up here because when I say the words, you know what it means really quick. You're just going to use railroad tracks. Railroad tracks to get it alone. What you're doing is you are going to solve the equation for the variable C, which means you got to get C alone. In intermediate school, they always refer to that as using railroad tracks, right? So I want to get C by itself, so I do the order of operations backwards. I'm going to minus 32 from both sides, and I end up with 40 minus 32 is 8. Over here, I still have 9/5 C. 32 minus 32 goes away. Now, you learned, and again, maybe forgot, that when you're multiplying by a fraction, the opposite of multiplying by a fraction is to multiply by its reciprocal. You flip it over and multiply both sides, so that makes this one go away. On the left, 8 times 5/9 becomes 40/9, and on the right, I'm left with C. So I get the same answer we got earlier, 40/9, but this time I didn't have the formula to directly get me there. So if you plug in the numbers and your variable is alone, use the calculator. If your variable is not alone, then you got to get your variable by itself. and you've been doing that for years. So let's look at a couple formulas, and then we'll look at some unique situations. So we're going to skip permutations, combinations. We're going to come back to that because those ones are a little bit different than a normal formula. Let's go down to simple interest. This is something that we'll use this year a little bit. So I equals PRT. So interest equals principal times rate times time. That's what all those variables stand for. Sometimes it helps to know what they represent. The I is the money that you earn in interest. The P, the principal, that's the money that you put in the bank. The R is the rate. That's the percentage that you're earning on that money. And T is for time, which is the time that your money's sitting there in the bank. So let's say that it gives me let's go with, I earn $300 in interest. That's not easy to do. Congratulations. Let's say I started with P. I started with $5,000. And I don't want to solve for a percent. So let's say our interest rate is 2%. What I don't know is the time. I'm looking for the time. Well, when I look at my formula, time is not by itself. Time is over here with principal and rate. So I'm going to have to do some railroad track stuff and figure out what the time is. But let's plug in what we know. Interest, I equals 300. So on the left-hand side, I'm going to write out my formula. 300 equals P, principal, is 5,000. I'm going to go ahead and put that in parentheses. Rate is 2%. The cool thing about the calculators in our class, they have a percent button. So you could put 2%. That is one option. The other option is to make it a decimal, and that's the one that you're a little bit more used to. I don't write 2%, I write 0.02. And then T is what I don't know. I'm looking for T. So I want to get T by itself. In order to do that, T is getting multiplied by 5,000 and 0.02. So I need to move those to the other side, and I do that by doing the opposite of multiplying by 5,000 and 0.02. So I'm going to divide by 5,000, and I'm going to divide by 5,000. And I'm also going to divide by 0.02, and I'm going to divide by 0.02. And after I do all of that, whatever I'm left with is going to represent my time. Okay. If you wanted to make the algebra a little bit easier, we could do things. We could clean up the right side before we did all the division. 5,000 times 0.02. This part right here, I can put in my calculator, and I end up with, let's see, 2% of 5,000 is going to be 100. 2% of 5,000 is going to be 100. That sounds right. So I've got 100T equals 300. Now I'm going to divide by 100. And I end up with 3 equals T. So what that means is in 3 years, if I have an interest rate of 2% on $5,000, in 3 years, I'm going to earn $300 in interest. Not too bad. All right. Let's do a couple. No, not yet. Let's go to distance. Let's go to the distance formula. So this formula, you're familiar with. It tells you the distance between 2 points. And it's got some weird notations. X2, X1, Y2, Y1. And if you go back to 9th grade in middle school, you learned what those represented. So if I'm looking for the distance between 2 points, let's say 10, 12, and I don't know, -6, -2. So those are my 2 points. The X1, X2, Y1, Y2 comes from the coordinates. So this is X1, this is Y1. That is the X value and the Y value from my first coordinate. This is the X value and the Y value from my second coordinate. So I'm going to plug in 10 where I see x1. I'm going to plug in 12 where I see y1. I'm going to plug in -6 where I see x2, and -2 where I see y2. So distance equals square root, parenthesis, x2 is -6. I'm going to put that in a parenthesis. And then I'm going to minus x1. x1 is 10. I'm going to put that in a parenthesis. And then I'm going to put my parenthesis with this squared after it. Then I'm going to add, this is a long one, my y2 in a parenthesis, -2, minus my y1, which is 12, parenthesis, parenthesis, squared. That looks like a great big ugly mess. You don't have to do that by hand. You can go ahead and plug that in your calculator. What the calculator is going to do, let's see, -6 minus 10 is going to be -16, and that's going to get squared. So you're going to end up with -16 squared, plus -2 minus 12 is -14 squared. You plug that in your calculator. You could do either version. You could simplify it first. If I were you, I would not. I would plug this right into my calculator and make sure it looks exactly like that picture and hit enter and get an answer. If you made a mistake doing the -16 and the -14 in your head or in the calculator, and then you plug them into the calculator with this formula, now you got it wrong. So there's no reason that very first one you can't just plug right into the calculator and get an answer. If you wanted to know the midpoint, you could use this formula and the same values that you've already used to find the midpoint between those 2 points, all right? A couple weird formulas that don't always, they have numbers in there, letters in there that may not always represent what they do in other formulas. So let's go up to our permutation formula up here. So our permutation formula says little n, big P, little r equals n factorial divided by n minus r factorial. This one's a little bit different because P, in this formula, P is not a variable. P is an operation. It's called permutation. Basically, this formula is saying if you take n number of people, so let's pick numbers. Let's say n equals, let's keep this simple, 6, and r equals 3. So what this equation is saying is if you have 6 people and you permutate 3 of them, you end up with this number. So P in this case isn't a variable, even though it kind of looks like a variable. So when you're plugging in your n and your r, you get 6 over here, P over here, 3, well, that is an ugly 3. 3 over here equals 6 factorial, parenthesis, 6 minus 3 in parentheses, factorial. On the left-hand side, maybe you've had my class before, maybe you've learned how to do a permutation. You can actually plug this right into the calculator if you know how to do it. If not, you could also plug this side into the calculator. Either one of those, the calculator knows how to do the math and solve those problems. So in this case, your answer is not going to end up P equals some number. Your answer is going to be 6P3. If I have 6 people and I permutate 3 of them, I get a value. And that's going to end up being 120. Combination works the same way. The C in this formula isn't a variable, it's an operation. So you got to be a little bit careful with formulas that you're not familiar with. Sometimes you will see a universal one. Things like R stand for different things in different formulas. Sometimes R can stand for rate. Sometimes R can, like in that permutation problem, that's telling you how many people you're choosing or permutating. In this formula down here, if I look at A equals PE to the RT, in this one, it represents rate. T represents time. P is not an operation. It represents principle. E universally does not represent a variable. Either does the lowercase I. If you notice in the formula up here, it used an uppercase I. If it's a lowercase I is I, just like pi is equal to pi. E is E. E is a mathematical number. It's an ugly number. That's why we write the number E. I is a mathematical number. I is the square root of -1. We don't want to write the square root of -1. We just write I instead. Pi is 3.14, blah, 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 forever, right? We don't want to write that, so we just write pi. E and I and pi are universal, okay? Those aren't ever going to be symbols. Those are values in the math world. Other letters can change. Other letters can represent different things along the way. So just be careful if you ever come across a formula that you don't know, that you make sure that you understand what the values represent, all right? So in class, we're probably going to go over more examples. I don't want to in this video. It's long enough. There are more examples of formulas down here that you're going to use the exact same way. If I'm looking for... if I know that E, I don't even know if these numbers are going to make sense. If E equals 75 and K equals 12 and D equals -7, then 75 is going to equal 12 times Q. I don't need to put Q in parentheses. It's not a value. -7 squared. I do railroad tracks and I get Q by itself, right? So all the formulas are you're going to go through the same process. Just make sure when you substitute, you put them in parentheses so that when you type it in the calculator, it matches and it does things in the right order. All right, your homework is at the bottom, or I guess maybe the back side of your homework, of your notes page. You've got a bunch of variables that I gave you values for, and then I told you which formula to use. So in the homework, it says temperature. It wants you to use the temperature formula to figure out what is C. Permutations. I gave you a permutation and a combination problem, and I gave you the values of N and R in the formula. Simple interest tells you to use the simple interest formula. Compound interest, use the compound interest formula. You're noticing a pattern, right? Pythagorean theorem, use the Pythagorean theorem formula. So all of these problems tell you which formula to refer to, and you have them on the other side of your paper. So good luck. Come see me if you need help.